My name is Emma. I'm the project manager for the NASA Hunch group.
I'm Kennedy. I'm the communications manager.
I'm Austin, and I'm head of data and engineering.
Before we get into our project, I wanted to explain exactly what it is because I just said two words that you probably haven't heard with the other groups, which is NASA and Hunch. Now, we all know what NASA is, but you might not know what Hunch is. And Hunch stands for High Schools United with NASA to create hardware. And we had the opportunity to work with them to basically create an extreme science experiment and then take it on a zero-gravity plane and test it. So, like I said, Hunch is just a partnership between high schools and NASA. They provide materials such as our budget, but they also provide any mentoring that we need. And their goal is basically just to inspire innovation and creativity through high school students using science. So our objective was to test a healthy heart and circulatory system in space, and then compare that to an unhealthy heart in space. And both of our hearts are right here, and they're represented by two pumps, and they're all identical except for a degree of blockage. One heart has more blockage, meaning the arteries are bigger, and then the other is smaller, and those represent unhealthy and healthy systems.
So what we have made here is a system using peristaltic pumps which rotate and they push the liquid in tubing. So they rotate and push the liquid out. So using those, we were able to set the voltage to each peristaltic pump and create the beats per minute of the healthy and unhealthy heart. And by using the beats per minute, we then got our data through running it through the pressure sensors, which are about this big on the bottom, and then through our flow meters, which are up here. So we got pressure and flow. The pressure sensors are placed behind the blockage, which are these weights. I don't know if you can see them. You can come here and look if you want. They're silver weights, and they are grams, and they push down on the tube to create about 60 to 70% blockage on the unhealthy and block about 20% on the healthy. That just represents gravity pushing on your regular circulatory system.
So the purpose of this is to test it in a zero-gravity environment, which we were lucky to do. And it's designed to show the effects of zero gravity on, like I said, an unhealthy and healthy heart. And just to see if those in the future that may want to go into space, how their bodies might react. So this is sort of like an example of what could happen in that situation. And here's our timeline. All of the things listed above we have completed, and our final timeline, which is our final report, which is going to include all of our data and what conclusions we came to, what if we proved our hypothesis or if we didn't, and that will be due on the 1st of June. And as far as our budget, we were given $2,000 to work with, and we spent $1,971.02, and we have $28.98 remaining in our budget.
So we've already told you about what the experiment does. What this experiment has brought to us is we've learned a ton about hearts. We have learned circulatory system functions, we've learned what happens under different pressure, like what happens under a stroke or a seizure or blood pressure shoots through the roof. Using these switches right here, we were able to set different speeds to different sides of each sides of the pumps, and we were able to change the pressure. We weren't able to change pressure, that was changed based on gravity. We were able to change the speeds and change like it was accelerated, so they were hyped up, like their hearts were beating faster, or they slowed down, they were rested. So by using the switches, we were able to run the hearts and the pumps through different scenarios. So with the data we got really accurate data, like to the 0.0001, like 100,000, sorry. And right now we don't have our data because we have about 1.2 million points of data, and it's taking me a while to go through that. Yes, but our data, I wish I had a picture of it, because we went in parabolas that lasted about 30 seconds. We went up, and then went down, and the down was terrifying. Up, and then went down. I got very sick. But if you look at our data is, when we're at the 0G, when we're at just the regular gravity, the 1G, it's perfectly flat. It's the regular pressure we'd experience on the system, and then we go up in the hyper G, which is the 2 to 3 Gs. The pressure is greatly increased. The pressure is almost 300 points higher than when it is at the bottom. Then when we crest, it immediately spikes back down. So it's like no pressure on the system. So if you look at our data, it's just like this the whole entire time. So our system worked fantastic, and everything was recorded to a SIM card that went here in our little nifty box of joy. And everything was stored in here, just pop the SIM card out, and then we are currently going over data.
So I'm trying to understand what's the end game here?
So the end game, so what we're testing is an unhealthy heart. We know what the healthy heart's going to do, because there's tons of research on healthy hearts. Astronauts have to be healthy when they go into space. We're testing an unhealthy heart to see if that person that has that higher blood pressure, or that has that blood clot, or that stroke, can survive in that zero and hypergravity environment. If the readings we get show that they can't, then they obviously die, or they get close to that.
Did you build this?
Yes.
That's impressive.
Thank
What was your cost of putting your presentation together?
This right here, or this?
All of it, everything.
So this costs about $1,900. It doesn't look like it costs that much, but to me it doesn't. But the bulk of the money's in here. It's the SD cards, the nano chips, the altimeter, which is able to regulate the seat gravity. The pressure sensors were expensive. The peristaltic pumps, which are down here, were expensive. Building this thing was a very big pain. We had one before this that me and my friend Evan built, and we were in the bathroom for hours shooting blood across and trying to clog up leaks and everything. So finally we came up with this ingenious system which has not leaked and will not leak.
Have you thought about putting, you were talking about test heart rate, BPM, I see 2 switches. Have you thought about making it dialable for testing like a heart rate between resting rate and an extreme high rate then to let you check all the variables?
So
or?
These pumps NASA gave us because they're really the only ones that tested that can actually pump in that environment. And just because the liquid doesn't ever touch the pump system. The liquid rotates and pushes the tube. And other peristaltic pumps were a lot more expensive, a ton more expensive. And we could definitely regulate, I mean, it's all about voltage. That's what we figured out. We tested different voltages to see how we could get the different beats per minute. And I guess we could do something like that. That'd probably be in the future. But right now we set a high and we set a low. And we want to test the lowest point, you're at home chilling, and then the high point you just got done after a run. But that definitely could be
just took
achieved.
off in a rocket.
Yeah.
Any other questions?
How was it in the plane? Did you enjoy it?
It was a really cool.
We had a